Now we've got a question about equilibrium. So sulfur trioxide decomposes to form sulfur dioxide and oxygen at temperature 1 according to the equilibrium shown. And we can see that this is an endothermic reaction because of the positive delta H. So the graph in figure 4 shows the concentration of sulfur trioxide and oxygen over a period of 6 minutes at temperature T1. What they would like us to do is to state the time to the nearest minute when equilibrium is first established, and we're going to have to explain how we got to that. Now, my initial thought is then, what do we mean by equilibrium? Well, it tells us that the rate of the forwards reaction is equal to that of the backwards reaction. Now, our graph actually shows the changes in concentration. So the implication of the rate being the same then would be that the concentrations would appear constant. So looking at our graph, we're looking for points where the concentration of O2 and the concentration of SO3 appear to be constant. So if I look, I can see my lines become parallel around here, which is closest to 3 minutes. My explanation being then exactly what we've just said, though, because the rate of the forwards reaction is equal to that of the backwards reaction at equilibrium, the concentrations would remain constant. Now the next question then wants us, if you just hang with me a second, there we are. The next question wants us to sketch on the graph how the concentration of sulfur dioxide would change over these 6 minutes. Now, looking back at our equation then, we can see that sulfur dioxide and oxygen are being produced in a ratio of 2 to 1. So looking at our graph, we can see the final concentration of oxygen is 0.15 moles per decimeter cubed. This suggests then that our concentration of sulfur dioxide would be double this. So our final concentration of sulfur dioxide would be 0.3 moles per decimeter cubed. So this would be our end point. Now, again, because it's at equilibrium, the concentrations would appear constant at around 3 minutes. I'm just going to make a point on my graph there where that would be. Now, we know that sulfur dioxide is a product, so the starting concentration is going to be 0. So I'm going to very carefully draw a smooth line that runs through the origin, plateaus at 3 minutes and ends at 0.3 moles per decimeter cubed. The next question then, we're told, just give me a second, that's better, we can actually see what I'm doing now. So we're told that the temperature of the mixture was changed to temperature 2 and it was left to establish a new equilibrium. In the new equilibrium mixture, the concentration of sulfur dioxide was found to be 0.07 moles per decimeter cubed. So we can see then that that's much lower than what it started as. We can see that's much lower than it was with temperature 1. So because this is lower than the other one, it tells us that there is less sulfur trioxide. Okay, so going to my equation then, we need to think about whether that tells us that T1 or T2 is the higher temperature. So we originally looked at this and said that the forwards reaction was endothermic. Now, because of our understanding of equilibrium, we know that if a forward reaction is endothermic, the reverse reaction must be exothermic. So that tells me that heat would be released with sulfur trioxide. Now, if there is less sulfur trioxide. It tells us that the equilibrium in temperature 2 has shifted to the right-hand side. Okay, so if equilibrium has shifted to the right-hand side, that must be because the temperature has been increased. Okay, so the higher temperature must be T2. The reason being that equilibrium has shifted to the right in the endo direction. Just move that down a little bit. To oppose the increase in T. So just to repeat that, going back to our equation, temperature 2 must be higher. We have increased the temperature, which has shifted the equilibrium to the right to produce more sulfur dioxide and more oxygen. Therefore, there is less sulfur trioxide.